Okay, let's take a look at the actual definition of sine theta. For so long we've thought SOHCAHTOA, that's what they taught us, why wouldn't we believe it? SOHCAHTOA is a magical Candyland way to introduce grade 10, 14, 15, whichever year-olds to trigonometry, but sine actually has more to do with a circle than it is a triangle, but if you are so inclined, every circle you see actually has an infinite number of triangles. Try and imagine that. We'll work on that a little bit later. So let's take a gigantic circle. And I didn't do it to scale, but we have a radius of 1. And I'm going to put the 1 right there. So again, the unit 1, circle with radius of 1, has an equation, and we're going to talk about that later in the chapter. But for now, we're going to get back to the definition of sine theta. So we're going to keep the definition SOHCAHTOA, sine theta equals opposite over hypotenuse. But now we're going to learn a new definition of sine theta. So I'm going to make a triangle. And if you're looking at your notes, feel free to look, mark around the sheet. There's a lot of white space that you can draw on. And then I'm going to make a larger triangle. And I'm going to call this length 2. So what I've done is I've taken the old hypotenuse of the unit circle with a radius of 1, and I've increased that hypotenuse to 2. And for the sake of it, let's put in an angle of 30 degrees. And sine of 30 from many times in grade 11 and 12 already, earlier in this section before, we know that sine of 30 is equal to 1 over 2. So if I outline the red large triangle, and I know that the definition of sine 30 is 1 over 2, I need to know that the opposite must have a 1 if my large hypotenuse is 2. Therefore, my definition of sine theta equals opposite over hypotenuse. Therefore, sine 30 is equal to 1 over 2. And that's the large red triangle. Now, from similar triangles in grade 8, I suggest you go back and review these topics if you're not up to speed with them, because your teachers are going to go very fast. So, once again, in the large red triangle, I have an opposite of 1 and a hypotenuse of 2, and the small black triangle just has a hypotenuse of 1. So how much bigger is the triangle? Well, the red triangle is 2 times as big as the black triangle. Therefore, if I have an opposite of 1 in the big triangle, and I know that I have to divide it by 2, I have an opposite of 1/2. Now, here's where we get to it. So I'm going to put a point on the unit circle. A big, huge point on the unit circle. Now, that point is x, comma, something. Well, what? Well, I can clearly see that that y value is 1/2 from the work we did with similar triangles a second ago. So I know that that x is equal to 1/2. And I know that the small triangle, the sine of 30, is equal to opposite 1/2 over 1, which is just 1/2, which is the same as the 1/2 from the big triangle. Now, what am I trying to get to? Well, what I'm trying to get to is that every single point on the unit circle is simply cos x, comma, sine x. So whatever the sine of 30 is, in a triangle with a hypotenuse of 1 inside the unit circle, sine theta, or sine x interchangeably, is simply, you know what, I'm going to go back to theta for this purpose because it does get confusing. X, cos theta is the x value, sine theta is the y value. So again, if I ever have a triangle with a hypotenuse of 1 in the unit circle with an angle of 30 degrees, sine is just the y value. So my point is just x, comma, sine theta. And our new definition, sine theta equals y. This is the actual definition of sine theta. Sine theta is equal to the y value of the unit circle, only, always. It just so happens with similar triangles, we've been able to introduce it to grade 10s with very simple arithmetic and algebra, that it's also sine theta equal to opposite over hypotenuse. So we're going to be using both definitions. Now, as we saw from the point above, cos theta is just equal to the x value of the unit circle, and that is the definition of cosine. And now I will write the definition of cosine from grade 10. Cos theta is equal to adjacent over hypotenuse. And we're going to be using that one interchangeably, but the definition of cosine theta is the x value of the unit circle. It always has been. And if we look up at the graph, the x value of the unit circle, if we remember special triangles, will be root 3. So we know that point is root 3, root 3 would be the length of the large triangle. Therefore, if I divide that by 2, the length of the small triangle is root 3 over 2. And this point is x root 3 over 2, comma, y 1/2. Cosine theta being the x value and sine theta equaling the y value. Cosine theta is x, sine theta is y. And do not forget SOHCAHTOA, and we're going to be using them interchangeably back and forth all the time. If we have triangles, we'll use our SOHCAHTOA. If we have quadrantal angles, we'll use sine theta equals y and cosine theta equals x. And interchangeably, similar triangles, if you ever have two triangles, it's usually a good idea to draw them both side by side off to the right in exactly the same layout you were working with them above, and label them all separately and work with them like that, and then bring them back into the triangle. So let's just go for tan theta quickly. Tan theta is the opposite over the adjacent. Let's go for that one first. Opposite over adjacent. TOA. Now, what would its definition be with respect to sine, cosine, sine, and cosine? Well, the opposite is y. Therefore, tan theta equals y over x. The definition of tan theta, seen all over our formula sheets and everywhere else. It turns out that tan theta is just the slope, the rise over run of the point on the unit circle. And therefore, the actual definition of sine theta is the y value of the unit circle. We're still going to be using SOHCAHTOA. Cos theta is the x value of the unit circle. We're still going to be doing SOHCAHTOA. And tan theta is the slope of the unit circle. And we're still going to be using SOHCAHTOA. So, sine actually has more to do with a circle than it does a triangle. But again, try and picture the infinite triangles, and more specifically, the infinite right triangles in standard position. Okay, so let's draw a really nice little unit circle very, very carefully. So a nice axis. Now, for the purpose of this, I'm going to call a couple, or I'm not going to do it perfectly, so don't use my graph paper and behind if you can see it. So I'm just going to draw a circle, hopefully with a similar radius. And I'm going to put the radius of 1 right here. I mean, it's everywhere. It's here, and it's here, etc. And I'm going to mark 0 and pi like I always do, and 2 pi. And straight up would be pi over 2. You'll rarely see me do angled slash fractions, only when I don't have enough room. Down below will be 3 pi over 2. Because we have 1 pi over 2, and 2 pi over 2, and 3 pi over 2, and 4 pi over 2, etc. And then I'm going to put all the points on the unit circle. So I have this point off to the right, and that has an x value. If I have a radius of 1, will be 1, 0. And the point at the top, if I have an x value of 0 and I have a radius of 1, I'll have a y value of 1. And a point on the left, if I have an x value of -1, it's -1, and a y value of 0, the radius of 1 going in the other direction. And then if I have a point down here, it means that I have an x value of 0 and I have a y value of -1. So, where are we going from here? Well, first of all, I'm going to take out all these radiuses. They're a little bit confusing. So, I've gone a little bit more depth in the notes with the triangle off to the right and the point being cos theta, sine theta, or cos x, sine x. So let's get to the definition. Well, let's take this little tiny triangle in red inside the unit circle, and we just have a y value and an x value. And we know that the definition of sine theta was opposite over hypotenuse for so many years. And what's this new definition of y? Well, let's substitute. So let's say sine theta is equal to, well, what is the opposite of that triangle in the unit circle above? Well, the opposite of theta near the origin 0, 0, the opposite of that theta is a y value. And the hypotenuse of that triangle is 1 because it's the unit circle and it has a radius of 1. And sine theta equals y divided by 1. Y divided by 1 is just simply y. And we have our definition of sine theta. And we want to memorize that definition. And we want to not forget SOHCAHTOA. So, seen down below, what would sine of 0 be, for example? Well, sine of 0. And remember, that's in radians, and 0 degrees in radians is the same as 0 in degrees is the same as in radians. So sine of 0, well, sine of 0, that is this angle right here off to the right, 0, with my terminal arm going straight to the right. And sine of 0, well, I know from above that sine is the y value. So I'm going to circle the point on the unit circle. And I'm going to see that sine is just that y value. And that y value is the value on the right, which is 0. So the sine of 0 is 0. Let's do one more. Sine of 3 pi over 2 equals. Well, 3 pi over 2 is the angle going straight downwards with the terminal arm pointing straight downwards. So I will circle that point, and I know from above that sine theta is the y value of the unit circle. Therefore, the y value of that point is -1. Therefore, the sine of 3 pi over 2 is equal to -1. The y value of the point on the unit circle. So, let's take a look at cosine. Well, cosine theta is equal to adjacent over hypotenuse. So, cosine theta will equal to the adjacent of the triangle in red above is x. And the hypotenuse is 1, and we can cross the 1 off. So we can say cosine theta is equal to the x value of the unit circle. And we can put a box on around that. We've got to memorize that. That's on our formula sheets. That's everywhere. And that's the actual definition of the point. So now I'm going to put the point on the triangle. Well, I know that point is simply sine theta, comma, cos theta. Now I don't know what the angle is, but every single point on the unit circle is sine theta, comma, cos theta. Therefore, sine theta is equal to the y value. Oh my gosh, I wrote it backwards. I hope you're all paying attention. I wrote it backwards. Happens all the time. The x value is cos theta. The y value is sine theta. My gosh, excuse me. That rarely happens. I mean that when you're doing it, it happens. Be careful. Cos is x, sine is y. Sine is all about the opposite, which is y, which is vertical. Cos is all about the x, which is horizontal. So let's do an example from cos down below. So cos of, let's pick an angle from the notes. Cos of 3 pi over 2. Cos of 3 pi over 2. Well, we know that that's just the x value of the point going straight down with the terminal arm pointing straight down. And that point, circle it, has an x value of 0, so the cos of 3 pi over 2 is 0. Feel free to check all these on your graphing calculator. So we've got some examples about tan. When the adjacent is 0, it's undefined. We're going to get into that more into the next chapter. We've got some examples down below, like cosecant and secant and cotangent. Why don't we do secant theta? So let's do secant theta. It's in the middle. So secant theta, I know, is the flip of cosine. Remember, if the s is first, it flips with the one with the c first. So I know that's h over a. Therefore, secant theta would equal the hypotenuse x over, 1 over the adjacent x. Now, let's do an example for secant. And keep in mind, we do not need to memorize that formula. We can always work through it, SOHCAHTOA. So, we know that if I substitute into that formula for an example in the notes, secant of pi over 2. Secant of pi over 2 equals, well, I know that secant is just 1 over the x value at pi over 2, so I'm going to circle pi over 2 at the top. I'm going to draw in my terminal arm going straight up, and I'm going to circle my point. Well, I know that secant is just 1 over the x value, so I'm going to underline the x value, it's 0, and I'm going to say 1 over 0. Therefore, secant of pi over 2 is equal to undefined. We cannot divide by 0 if 0 is ever on the bottom. We also could have used the definition as seen in the notes that secant is 1 over cos, and if I substitute what 1 over cos was, cosine was 0 at that value, and then find out that it's undefined using a different route. So in this video, I've gone one way, and in the notes, I've gone another. Lots of the times, I'm going to go back and forth or accidentally do that. But notice we have 3 examples. We just simply want to remember SOHCAHTOA and our 3 new definitions. Sine theta is y, cosine theta is x, and tan theta is the slope y over x, rise over run. Keep in mind, we're going to be using this unit circle again a lot in the next chapter. So when we bring back to it, either study these notes again or start watching the videos and try and remember what we did here.